Alright, welcome back to our CNT 140 class on LAN wiring. This lesson we're going to be covering the Chapter 16, Monitoring and Administering LAN Wiring. Now the objectives that we will be highlighting will be LAN system documentation, the EIA/JA606, cable system monitoring methods, SNMP monitoring and control, and remote control. So let's get started. A LAN wiring system is a dynamic entity in many ways, changing and growing much like a living thing. If the LAN operating system is like the lifeblood of your network, the signal wiring certainly is like the nervous system, carrying important messages from point to point. LAN wiring must be monitored and tracked so that you can constantly know the status of your interconnections. LAN wiring systems are not truly passive systems. They are active in the sense that they can change characteristics over time, and they can disrupt the LAN if they fail. When a failure occurs, we only need to make quick repairs. So how well you are able to respond to a cable problem depends on the methods available to you to isolate the problem and find the offending cable system component. Proper documentation of your wiring will assist you in your installation and troubleshooting efforts. This is the essence of monitoring and administration. Cable system monitoring methods. Monitoring of a cable system can be accomplished either directly or indirectly. For most installed LAN systems, the networking equipment, servers and workstations, can do a part of the job indirectly. We call this indirect monitoring because it is part of the normal operations of the connected systems, which sense the status of the network links indirectly. If a workstation cannot connect to a server, it may mean that there is a connectivity problem, such as a bad cable or other wiring component. Unfortunately, indirect monitoring of the channel may indicate a communications problem even when the cable connectivity is fine. For example, a bad workstation, network interface card, or a software problem at the workstation switch or server would appear as a network communication problem, even though the cabling is good. Direct monitoring uses the capabilities of the hubs, patches, or network interface cards to directly monitor the cable link. This type of monitoring senses the condition of a cable and allows direct control and/or testing of the channel. Direct monitoring may be done on either a local or remote basis. Local monitoring simply uses the built-in status indicators on hubs and NICs to monitor link status. One simply looks at the LED indicators on the devices. Now, of course, this assumes that the devices you're using have indicator lights. Remote monitoring uses an intelligence built into the hubs or other network devices to report status to a monitoring station. Remote monitoring can use a standard networking monitoring software such as SNMP, which we'll talk about later. Remote monitoring is rather new and offers an exciting new view on the LAN wiring as a separable entity. It is unfortunately still somewhat too expensive to implement on the low-end and low-end networking devices. However, as network speeds increase and as cost network equipment decrease, it will become more sensible to use monitoring devices to determine the system of the wiring. Let's look at the physical cable monitoring. Physical cable monitoring on installed LAN wiring systems presents some very special problems. Most of the simple ways that can be used require that the monitoring be performed by the connected LAN devices, such as the 10100 base T or token ring hub. The hub monitors the condition of the link and then reports by indicator lights at the front panel of the hub or by sending messages to a remote monitoring station. These devices and their capabilities are specific to the type of LAN that you're using. All 10 base T, 100 base TX, and gigabase Ethernet twisted pair systems provide a positive indication of link operation. A continuous link signal is built into the physical layer protocol. It indicates both link status and link speed. Standard 10100 gig systems actually only evaluate the integrity of the received signal from the other end of the link. But enhanced systems can indicate integrity of the complete link, local and remote, and report the link status to a remonitoring system. Token ring MSAU, in contrast, uses DC connectivity on the link to set or reset a sensitive relay in the MAU. Now, even a simple multi-station access unit can easily provide an LED indicator on the front panel to indicate link condition. Intelligent MSAUs are able to report the status of any load to a remote monitor. Of course, the indication shows that more than just the integrity of the cable, because the workstation operation is also a factor in load status. Nevertheless, this is an effective means of physical monitoring. Now, if we look at remote cable system monitoring, another type of direct cable monitoring system pays no attention to the LAN protocol, but has custom electronics that are designed to indicate the integrity of a connection. These monitored patching systems can provide connectivity monitoring with virtually any type of LAN. The way this works is that these systems use pairs on the cable that are unused by the LAN to indicate connectivity, and in some cases even the cable map, where each patch cord terminates. Now, for example, 10 base T, 100 base T, and token ring use only 2 of the pair on the cable. The other 2 are available for other purposes, such as connectivity monitoring. Now, while this does not truly indicate that the 2 network pairs are connected, it certainly will indicate whether a patch cable is connected or disconnected. Some systems can even detect where a patch cord has been moved to and report an alarm to a monitoring station. Now, the monitored patch system, as shown behind me, is an example of this capability. Now, SNMP monitoring control. Effective remote access to network devices may be provided by using the simple network management protocol. This protocol communicates over the network to a management workstation via an extension of the popular TCP/IP suite. Monitoring on all sorts of hubs, bridges, and routers and other devices can be accomplished by using SNMP. SNMP management can be expanded to almost any device with a network connection. Some devices that have no native LAN ports, such as a T1 or E1 communication equipment, are now being equipped with a LAN port just for an SNMP interface. The SNMP-based monitoring and control techniques may also be applied to cable management, particularly with hub-based cable management. The SNMP is a welcome tool for both management and control. Some of the intelligent patch panel equipment can communicate via SNMP for both monitoring and control. Now, as network hardware becomes more complex, global network management solutions will become more important. Often, these management tools will offer some degree of cable management along with their functions. Remote control of physical connections. In some circumstances, you may have a need for remote control of your physical network connections. For example, you might want to disconnect or reconnect a workstation from your network monitoring location. This can be effective in preventing a single workstation from causing a global network problem. Many intelligent hubs and similar devices can provide this remote control capability. The most common method is to use in-band signaling via SNMP or proprietary protocol. However, this method does have one disadvantage. If your network is being jammed by an offending workstation, it may be impossible to communicate over the LAN to command the hub. Another remote control option is an out-of-band control system using a control port. This control port remains free of any network disruptions and can keep you in the game. A control port can also be used to make modern connection to a remote system, regardless of the network connectivity. Some remote controlled equipment can perform other monitoring functions such as environmental monitoring and access control. A remote temperature alarm could alert you to a condition that might eventually cause the devices in the equipment room to fail. Or you could simply have a remote system start to coffee before you arrive. LAN system documentation. Good documentation is the key to controlling your LAN wiring environment. Whether you're troubleshooting a LAN outage or simply adding a cable drop, having well-organized records will save you a great deal of time and trouble. The systematic marking and identification of all of the components of your LAN wiring system is an essential part of good documentation. Each item on the LAN wiring should be clearly marked with an identifying number. This applies to each cable, each termination, and all the points in between. As a matter of fact, many of the mounting structures and pathways that are used to support LAN wiring are best identified as well. LAN Documentation Standard TIA EIA 606A In an effort to standardize the administration of telecommunication cabling, the TIAs published this document, Administration Standard for Commercial Telecommunications Infrastructure. This standard covers the identification, nomenclature, and documentation of wiring, pathways, and grounding and bonding in commercial buildings. It also suggests a system of drawings, work orders, and computerized record keeping to help manage the wiring system after initial installation. The figure behind me shows some of the wiring system elements that are expected to be identified and recorded. The 606A is quite detailed and specific, going far beyond the norm in some areas. However, it provides a very useful documentation and administration plan from which to keep your modeling record, model your record keeping. Now, the guiding rule for a proper land documentation system is mark everything. That is, systematically identify every outlet, cable, termination block, patch panel, cable pathway, telecommunications space. Then record those identifications on drawings and database for quick reference. If you do not carefully manage your LAN wiring installation, the constant pace of changes to the system will soon disorganize things so much that you'll be forever lost in the cabling maze. The extent to which you need to implement the full complexity of the 606A system depends on the system of your cable plan. Large systems need much more careful documentation than small systems. Under 50 stations, but all cabling systems will benefit from proper record keeping. So what do you document? Well, as a minimum, the wiring outlets and cable terminations, patch panel, jacks, punch-down blocks, all need to be given identifying numbers. It's also a good practice to permanently label the ends of each cable run. Telecommunication outlets should be clearly numbered, and standard method is to place a label on the faceplate above each jack. Many manufacturers have responded to this requirement with special faceplates that have a recessed label area below a removable protective plastic cover. An example of these faceplates shown here behind me. Now, patch panel jacks should also be labeled in the front of the panel. Labeling on the back is optional, but is a very nice feature for troubleshooting. Patch cords that run from cable terminations at the patch panel to the hub equipments are also numbered to make it easy to find which station cable corresponds to which hub port. Patch cords should be numbered with a removable label, if possible, as they are intended to be moved around. This practice makes it easy to identify the proper jack location for each cable end. Perhaps in a very small installation, you'll be able to maintain a one-to-one correspondence between the two patch jacks, but a larger facility will soon lose the neat arrangement. There is nothing worse than a loose patch cord end hanging down with no idea where to plug it in. Large installations will benefit from the labeling of cable pathways such as ducts, sleeves, cable trays, and conduit. Raised floors, while not directly marked, can also be identified in drawings showing grid numbers for each work floor area. Work area and telecommunication spaces should also be identified with a marking at the entrance to the area. For many buildings, this requirement is easily handled by existing room numbering. Additional information is then recorded along with the identification number of each element in the wiring system. The exact information required varies with the type of item, but it always includes the identifier and the item type. Additional information may be needed as the numbers of available positions and whether any are damaged, as in bad pair or multi-pair cable. The administration standard also requires that the information recorded for each wiring element be cross-linked to any of the records that are related to that. For example, a cable identifier must be linked to records of termination, position, splices, pathways, and grounding. A list of the item types, information to be recorded, and record links is shown here behind me. Information may be needed as to the numbers of available positions and whether any are damaged, as in bad pairs or in a multi-pair cable. The administration standard also requires that the information recorded for each wiring element be cross-linked to any other records that are related to it. For example, a cable identifier must be linked to records of termination, position, splices, and pathways and grounding. list of the items are shown here in the table behind me. As you can see, there really isn't a whole lot of talk about with monitoring and administering LAN wiring. After all, once it's in and certified, it really becomes somebody else's problem. So that's it for now. Move on to your online assessments, and then I'll see you in class where we can have a whole lot of cabling to test and certify. See you.